Okay, here we are on the lesson 2, comparing and ordering rational numbers. You'll notice the first thing it has that what you'll learn. It says scan a lesson. So go ahead, pause the video for just a minute, scan the lesson, or see what you can remember about common denominators and least common denominators, and then come back and fill those in. We'll do that together. All right, I'm starting the video back up right here because this is where they discuss the two things they wanted you to scan. So if you didn't find it yourself, there it is. You can see what it says about common denominators and least common denominators. And the best way that I have found to think about this, I'm going to go back now. Common denominator is a number both denominators go into. And by the way, if you already wrote something on this line, you don't need to cross yours out and write mine, as long as yours makes sense. So a number both denominators go into. The least common denominator is the smallest number. Both denominators go into. And the reason why we use the least common denominator is that it just makes the work easier to do. Just the same reason why we simplify fractions. It makes it easier to understand. So this lesson also includes a little bit of work here with the idea of rational numbers. Rational numbers are numbers that can be expressed as a ratio of two integers written as a fraction. It sounds fancy, but what it basically means is any number you can really turn into a fraction, whereas irrational numbers, you can't do that. And then as you move down, you get integers. Those are positive and negative numbers, whole numbers. And then you get whole numbers. Those are just positive whole numbers. So if you were filling these in, for example, go down here, the 1, that's a whole number. Cha-ching. The negative 1, that's an integer. And integers, again, are whole numbers and they're opposites. So that's the opposite of positive 1. Cha-ching. And then the other 3 of these all fall into the category of rational numbers. Rational numbers are fractions and then decimals that repeat or terminate mixed fractions and so on. Here's a real-world link. I didn't find this one too interesting or too informative, so we're going to skip that, and we're going to go to this next page and right into example 1. So in these examples, they are asking you to put numbers in order, kind of in order, actually comparing numbers. And we use these comparison symbols. And let's write these comparison symbols out here. So we have 3 comparison symbols. We have that one, which you're used to. That is equal to. That's any time two numbers are the same value. They might not look the same. For example, 1/2 is equal to 5/10. They don't look the same, but they represent the same amount. The second comparison symbol is this one, is less than. The smaller number, and then the symbol, and then the bigger number. So, for example, 2 is less than 5. And then our last comparison symbol, this one, is greater than. Please be making these notes. That's the is greater than symbol. And if I take the same two numbers and just change their order, 5 is greater than 2, and then I change the symbol. So they ask you to take these two values, these two rational numbers, negative 1 and 5/6, negative 1 and 1/6. And which of these would be true? Well, the one that would be true is the less than, because anytime you travel this way on a number line, things get smaller. So when you're traveling to the left on a number line, your values get smaller. They get further away from 0. 0's out, I'm going to draw my number line, but I'm going to do this little squiggly thing, which means it's not all to scale. 0 is right there. Things are moving out. So what would you do? You can use that same idea. What would you do with this one? Use this number line to compare. Go ahead. Pause the video for a minute, write that in, and then come back. All right. So when you went ahead and compared those, you would divide this into ninths. And dividing into ninths is a little difficult. What I find easiest is go just a little more than halfway and put the 5. So that's 5 ninths. Actually, it's negative 5 and 5 ninths. 6, 7, 8, and then negative 6 is the same as negative 5 and 9 ninths. And then 4, 3, 2, 1. So there's the negative 5 and 5 ninths. There's negative 5 and 1 ninth. And so if we were writing those, if we were comparing them, well, here, you compare them. They didn't actually ask that, but let's have you do it. Write the two of them down. Okay, now pause the video and pick which of those symbols you're going to use. Are you going to say that they're equal to each other? Are you going to say that negative 5 and 5 ninths is less than negative 5 and 1 ninth? Or are you going to say it's greater than? So go ahead and pause and then compare. Okay, hopefully what you came up with is less than. Again, it's further on the left of the number line, further away from 0. All right, let's go down now. Fill in this circle with these to compare those two. Now, you might say, wait a minute, this is not quite as easy. And you're right. Let's scroll back up for just a minute. What made this simple was that these denominators were the same. Everything was in sixth. So now, you'll notice in this example, they've used a common denominator. They've said, what do 12 and 18 both go into? They both go into 36. So change them both into 36, and now they're much easier to compare. And since 21/36 is greater than 16/36, we know that the 7/12, which is the same as the 21/36, is greater than 8/18. So here are your 3 to do. Go ahead and pause. Looks like you're going to need some common denominators. Pause and solve them using those 3 symbols, then come back. Okay, so now it's time to compare these. So our first step is going to be to find a common denominator. What do 6 and 9 both go into? Well, they both go into 18. So for B, they both go into 18. So we're going to have 5 6, 7 ninths. These both go into 18. Well, 6 times 3 is 18. So 5 times 3 is 15 eighteenths. 9 times 2 is 18. 7 times 2 is 14 eighteenths. 15 eighteenths is more than 14 eighteenths. Greater than. Letter C. Let's do that work right here. So you have 1/5, and you have 7/50ths. Now, if you did B and you got it wrong, but you watched me do B and you said, oh, that's what I do, pause the video, do C and D, turn the video back on. Coming back, hope you solved those. If not, pause the video. All right, so in this case, what do they both go into? Well, they both go into 50. So you always want to check, does the small one go into the big one? It does. 7/50ths doesn't change. This is going to be 50ths. 5 times 10 makes 50. 1 times 10 is 10. 10/50ths is more than 7/50ths. And that is another greater than. All right, so pause again now in case you haven't done D. And if you have, just wait and I'll start talking here in just. All right, letter D. Both these are negatives. Now remember, when they're negatives, let's go back and look for a minute. See, when they're negatives, the one that has the most ninths is the smallest. All right? Up here, this had the most sixths. So that's going to be furthest away from the 0. So 16 and 10, what do they both go into? Well, the easiest thing the easiest thing here might be to just multiply them together. That's something you can always do. So that's what I'm going to do to solve this one. Letter D, right there. I've got, and I'm not going to, well, I will bring the negative, I guess. Negative 9/16. I'm going to multiply that by 10, and I'm going to get negative. I'm going to just erase my work here and make it a little easier to see my negative. And I'm going to get negative 90 over 160. Now, on the next one, I'm going to have negative 7/10. And this I have to multiply by 16, right? Here I multiplied by 10. I'm multiplying them by each other. So here I have to multiply 16. So my 16 times table, or my 7 times 16 times table, isn't great. So I'm going to use my calculator. I get 112. So 7/10 is 112/60. Negative 112/60. Negative 9/16 is negative 90/60. And that's going to be greater. Now you might say, but wait a minute, this is more 160ths. You're absolutely right, but it's negative. So when it's negative, if it's more of them, it's further to the left. If I had a number line, here's where negative 90 160ths is. Over here is where negative 112 160ths is. So you always have to be careful with those negatives. All right, let's look at the next example. Mr. Huang's class, 20% of the students own roller shoes. I remember when roller shoes were a big thing with kids. I don't know, maybe 5 years ago, you saw all kinds of little kids in roller shoes. In Mrs. Trevino's class, 5 out of 29 students own roller shoes. Which class has the greater fraction of students owning roller shoes? So the first thing they did was they changed them both to decimals. Notice that. Express each number as a decimal. It is so much easier to compare things when you put them in the same form. So either both fractions, both decimals, both percents, something like that, but not one of each. So here's a problem. Pause the video. Leave that example showing. Pause the video. Try that got it problem. Okay, here we go. Let's use this space right out here to do problem E. So 37% of the students like to bowl in the second period class. In the fifth period class, 12 out of 29 like to bowl. So we've talked about changing percents to decimals. There's a whole video on that if you need to go watch it. That as a decimal is 0.375%, or 0.375, as a decimal. The 12 out of 29, we're going to set this up. We're going to grab our calculator, and we're going to take 12 divided by 29, and we're going to get 0.41. Since that went out 3 places, I'll take this 3 places. 414. Notice that 3 is the one I'm rounding to. And this 7 says round that 3 to a 4. So I've got 0.14 or 0.414. And then I'm comparing those. So I know that the one that had 12/29 is the greatest. So this is the class. Fifth period is the class with the greatest fraction of students who like to bowl. All right, ordering rational numbers. So here's an example. They talk about line up the decimal points. You can compare using place value. They've got these 3 decimals plus pi. So they put them all in the form of decimals. They changed the pi to a decimal. All right. So go ahead and do that for letter F. Pause, do letter F, turn it back on, and we will have an answer. All right, so let's take our values, and I'm going to use arrows here. 23%, right here. 23%, that is 0.23. 0.21 is 0.21. We're going to leave that in the form that it's in. We're putting everything into decimals this time. Now you could choose put everything into fractions, put everything into percents. Decimals is usually the most flexible, so that's the one I'd recommend. 1/4. The decimal for 1/4 is 0.25. And lastly, 1/5. The decimal for 1/5 is 0.2. You can grab, if you don't remember that one, 1 divided by 5, 0.2. So now go through and ask, which of those is the biggest? Well, they're all 0.2s. This is 0.25, 0.21, 0.23. I'm going to give that a 0 just so it has 2 places like the rest of them do. So the biggest, since the question is least to greatest, let's pick the smallest. This is the smallest right here. This is the greatest. This is the, see, I always find it easier to organize things. This is the biggest right there. There's the biggest one. There's the next biggest one. There's the next biggest one. There's the smallest one. So they wanted the smallest one first. So we're going to give them the smallest one first, which was 1/5. That takes care of this one. The next smallest was right here, 0.21. The next smallest was right there, 23%. And then the biggest one, 0.25, which was the original 1/4. Okay. We're almost to the guided practice. This is going pretty quick. Nolan's a quarterback on the football team. He completed 67% of his passes. I think that's pretty good, actually, in the first game. He completed 0.64 in the next game, 3/5 in the game after that, 69% in the next game. List Nolan's completed passes from least to greatest. And here you go. Now they took all these and they changed them in to decimals, and they did least to greatest. Here was the smallest, followed by here, here, and here. All right, so you've got a couple got it problems to try here. We're going to do got it problems 1 through 4. So pause the video, come back, and then the instructions are going to be when you come back, I'm going to go ahead and just start answering these questions for you. If you find that there's one that you got wrong and you think you know what you did and it means you think you got the next one wrong but you know how to fix it, pause the video and fix it. The goal is not how fast can we get done here. The goal is how can you do this most accurately. Okay, there we go. All right, on 1 and 2, you're asked to use the symbols is less than, is greater than, or is equal to make them true. Use the number line if necessary. So let's think about them 2 different ways. Let's use the number line and not use the number line. We'll do the logic and we'll do the number line. Let's start with the number line. So we need to divide this into fifths. So that's about a fifth, another fifth, another fifth, another fifth. We don't have to be, totally super accurate. We are just doing these to get a sense of how they compare to one another. So if we do that and we're comparing 4/5, negative 4/5 to negative 1/5, we can see negative 4/5 is further to the left, which means it's smaller. It's less than. The other thing you can do is you can say, well, this is more fifths. So it's closer to negative 1 than this is. And the closer it gets to negative 1, the smaller it's going to be. Getting past negative 1 gets even smaller. Number 2, 1 3/4, 1 5/8. This one, I would say, change those so they have common denominators. And this is going to be a nice one because you've got 4 here and you've got 8 there. The ones you don't have to worry about. So let's do this together. Let's use the space right here. 1 3/4, 1 5/8. We want to change them into the common denominators. Well, the whole numbers never change. If this is 1, it's going to be 1. 4 and 8 both go into 8, so you can bring this one straight across. This is going to be an 8. 4 times 2 makes 8. 3 times 2 makes 6/8. And now we can see 1 3/4 is a little bigger. How much bigger? 1/8 bigger. If we wanted to do that with the number line, you'll notice the 1 is already built in, so it's just the 3/4 and the 5/8. There's a half, pretty close to it. And if you're going in fourths, there's 3/4. And if you're going in eighths, there's 1/8, 2/8, 3/8, 4/8, which is the same as a half, 5/8, 6/8, which is the same as 3/4, and 7/8. Now, I should put ones in front of those because they are between 1 and 2, not between 0 and 1. But you get the idea. Again, we're trying to figure out which is bigger. Since they both have 1 as a whole number, then it's the fraction that we compare. Number 3, Elliot and Shauna both are both soccer goalies. I mean, I lost my chance to read there. Elliot saves 3 out of 4. Shauna saves 7 out of 11. Who has the better average? Well, I'm going to make this easy on myself. 3 out of 4, that's 0.75. I know that. That's one you should know. Think about money. 3/4 of a dollar is 75 cents. 7 out of 11, I couldn't tell you what 7 out of 11 is. There are a lot of things worth memorizing in life. What 7/11 is not one of them. So I'm going to use my calculator. 7 divided by 11, 0.6363. Now, see that 4? I know that 4 is just a rounding 4. It's going to keep going because there's a 6 after it that made it round up. So it's actually 0.63 with a line over it. Elliot was 3 out of 4. That's 0.75. Shauna was 0.633. Elliot had the better save percentage. He had the better save percentage. All right. And number 4. The lengths of 4 insects are 0.02, 1/8, 0.1, and 2/3 of an inch. List the lengths from least to greatest. It's always important to know what you're doing. Least to greatest or greatest to least. Well, 2 of these are already in decimals. So I'm going to make everything decimal. So I've got a 0.02. Let me skip the 1/8 for just a minute. I've got a 0.1. Of these 2 right now, this one's bigger, which means that one's shorter. Now let's just do the 2 fractions. 1/8 is 0.125. I happen to know that, but if I didn't know that, I could check it with a calculator. 1 divided by 8, 1 divided by 8, 0.125. That's going to go right here. That was the 1/8. Now this one is longer than that one because this is, actually, you know what, I'll wait, and then I'm going to put the same number of places once I'm done and know exactly how many I need. And then finally 2/3. Well, 2/3 is 0.6 repeating. 2 divided by 3, 6's repeat. All right? So I'm just going to give that 3 6's. And I'm going to give this 2 more decimal places, give that 1 more decimal place. So I'm up 3 on everything. And now I can look which is the smallest. Well, if I look in the tenths place here, this top one has no tenths. So 0.02 is the smallest. This is going to be the biggest. So now between these two, they both have 1/10. This has 2 hundredths. That has no hundredths, which means the next one on the list is 0.1, followed by 0.125, followed by 0.6 repeating. In their original forms, it would be 0.02, 0.1, 1/8, and 2/3. Okay, so check your knowledge on that. Come to class with questions if you have them, and then we're going to do some more practice in class.